Git is fantastic for managing projects across multiple collaborators, but that requires multiple collaborators. And when you have them all with their own computers, you need a single source of truth. That's where remotes come in. You want a single server to be the authoritative source of information and where you send your changes so that they can be synced with other people that you're working with who ostensibly don't work on the same computer that you're using. To understand a little more about how remotes work, before we jump into GitHub, and it's coming soon, let's head over to the Creating with Git repo that we forked and cloned down earlier. And we're going to cat out this thing's git config. Now, we've done this before, but with a little bit more information now about remotes, we may understand a bit more about what we're seeing. We now know that we have this branch main, which in fact has a remote set of origin. And if we look above that, we see that remote origin is configured to, well, GitHub. We'll learn more about what fetch means soon enough. This is obviously different than what we have with our Git demo repo. It has no remotes just yet. Remotes are copies of the same repository that live on another computer, and we can push changes to that remote, and we can pull changes from that remote, which executes merges on either end. But there's more going on here than meets the eye. If I run git branch in Creating with Git, you'll see I just have main. But if I run git branch -a, see, Git is actually tracking the remote branches as well and copying them down locally. So what happens in a Git clone is actually a mix of a bunch of different things. When we ran git clone to get that information down, what was actually happening was we created a new repo, we set up a remote, we got that information, and then we created a new branch based on that remote's information. Let's demonstrate that. To do so, we're going to head back over to our Git demo repo, and we're going to head over to GitHub. And we're going to click the plus button and go to New Repository. And we're going to create a new repository. I'll call it Git Demo. We'll describe it as Git Demo Course for Creating with Git. I'm going to make it private. It doesn't actually matter whether it's public or private in this case, but I'm going to keep mine private. I am very specifically not going to add a README file right now. Make sure you don't check that box. And go ahead and create the repository. Now, GitHub gives us some information about how to make this work. We don't want to use the top information. We do, however, want to push an existing repository from the command line. We already have git demo here. So indeed, we are going to git remote add origin git at github.com/your username/git demo. So we're adding a remote called origin, which is going to create this entry like we saw in Creating with Git in our own git config in the git demo repo. We're going to point it to this URL, which we're telling Git to use SSH and our SSH key to connect to that repo to authenticate and upload changes and download changes. We don't have to run the git branch -m main because our branch is already named main. That's why we did that. But we are going to run git push -u origin main. Git push is our first really remote centric command. It pushes our local commits to the remote copy of the repo and to the branch that our local branch is set up to track. But if we haven't set one up yet, -u is a shorthand for set upstream to. And what that will do is set our main branch to track the origin's main branch. Git push u origin for our remote main. And you can even see once it's done all of its stuff, it says branch main set up to track remote branch main from origin. And sure enough, if we cat our .git/config file, look at that. We see some of the exact same stuff that we saw before in our Creating with Git repo. Now, if we reload GitHub, hey, look, there's our stuff. GitHub is helpfully telling us that we should add a README. And we can click on that button and add a README. I wanted to do this because I wanted to use GitHub's own editor to make this change so that GitHub had something that our local copy of the repo did not. We don't have to do anything special here. We just wanted to use the online editor. This is fine. And then click commit changes, create readme.md. That's all fine. And yes, we will commit directly to the main branch. We don't always love doing that, but for now, this is fine. We just did a git push to send information to GitHub. You might think git pull is the opposite, to get information down, and you'd be right, but I don't want to use git pull first because git pull is actually two commands stacked on top of each other, disguised in a trench coat. And I want to use those two commands by themselves first so you understand that that's what's going on. Let's start by running git status here. It tells us that we're on branch main and that our branch is up to date, new information now that we have a remote, with origin main. But we know that that's a filthy lie. We just saw that readme.md was added to the GitHub copy of the repo and we don't have it. How can we fix this? The reason this is happening is because we haven't told our local repo to update any information from GitHub. That doesn't happen automatically. So while we can do git pull, the other thing that we can do is git fetch. And I want to show you what happens when we do git fetch. When we do git fetch, notice now that we get all of this information down. We have an origin main. And notice that our status tracker has changed. This minus sign indicates that our local branch is behind the remote. If we run git status now, it says your branch is behind. Now we can use git pull again to update the branch. But remember that we have git branch -a, and we have remote's origin main. So the other thing that we can do, and it is the exact same operation, is git merge origin/main. That will merge in the changes from the remote. And it's the exact same thing as running git pull. If we go back in time to our last commit, let's do git reset hard to this commit. So we're getting rid of that change entirely. Now it says that we're behind again. If we run git pull, notice that the exact same operation took place. So pull is fetch and merge in one move. We've now set up a remote for our git demo repository, and that's really all there is to it. In the next lesson, we're going to talk a little bit about responsible uses of remotes and how to responsibly merge changes into the main branch so that there's a management process that goes along with those changes.